Here we go. We're testing the PJ5. We've managed to make quite a lot of progress tonight. We've got a little test board here. Program counter, some bus bits which I'll explain in a second, and the clock PCB. We're in a single step mode at the moment. And what we have is our instruction decode here. We're set up to do a multiply. And what we've got is we have 3 buses. So we've got 2 registers. There's register A, which has got a value of 3, and register B, which has got a value of 5. And what we're going to do is read from this register, register A, and read from register B, and then right back into register B the result. So when we do 3 times 5, we should get 15 if my maths is right. So I'm going to single step and zoom in. There we go, 15. You can see that, so that worked. The displays down here change, they are upside down. That was a slight mistake, so if I turn it up that way it makes a bit more sense, but the bits are all down the wrong way, so we won't do that. Right, next step is we're now going to put it into run mode, and this is at a slow clock speed, she says. Switch into run mode, and you should be able to see that increasing. So we're doing hardware multiplies in 1 clock cycle here, which is really cool. Now we're going to ramp up the speed a little bit. There we go. I think I've gone back around on myself. Yeah, hold on. That's it. It's nice and quick. You can see the displays down here doing the nuts. You can see the program counter doing its nut. So the next question is, how fast can we run this? So that's the fastest on the slow speed. Now, there you go, you can see the multiply doing its thing over here. This is John's very clever modified Wallace tree. Lots of adders and AND gates. So when I flick this, we should go into 4 megahertz. So fingers crossed.
Do you want to turn the main speed down a bit?
Oh, right. Go on, we'll turn it down a smidge. There you go. We'll drop it down a little bit. Now we're going to high speed. Things are still flickering. I don't know if it's still working.
Well,
yeah, it's still going. I can see that this display is constantly flickering. So go on, let's go.
How high can you turn it up before it all falls over?
Let's do this. This is... if I slow it down, you can see, there you go. That's in the high range. You can see the LED's just about flickering. If I slow it down a bit more, there you go. And I can crank it up, and I think the only way we can tell now if it's still working is to stick a scope on it, because yeah, everything's kind of doing its nut. I'm not sure what speed we're running at, but it's pretty quick, so we'll stick a scope on. So a bit more detail, we've stuck the logic analyzer on here because the lights kind of stopped blinking at the fast speeds. We wanted to see what we're doing, and if you look at the multiplier and this, it's all kind of just maxed out. So we stuck the logic analyzer on here. You can see we are multiplying 2 numbers together at 4 megahertz, and that's 1 instruction per clock cycle, so that's 4 MIPS, and we are getting the correct results out of the multiplier. So yeah, we have a hardware multiplier and a processor. We can multiply 2 numbers together at 1 instruction per cycle.
And we have a problem with our clock board because it now needs to go up to a higher speed.
Yeah. Yeah, so now the challenge is, now we've reached 4 MIPS, how far can we push this? So yeah, that's the next step.